Physics debug window reference. In the previous video we saw how to create a vehicle with wheel colliders, and if you go into the software, if you go here, we name it wheel collider, so I just open it here, and pretty much this is the game. And if we go here and we go into game, just click play it. Okay, so we are gonna be able to play this game, so we can move it forward, we can move it towards the sides, we can move it backward as well. So this is the create a wheel collider that we worked in the previous video. Let's unclick it. So we have here the car root, and if we go inside into the child, we have the cube, and we also have the wheel as a child of this car underscore root parent. If we go inside of the wheels, we have, let's go into the scene. As you can see, this one, and if it's too bright for you, maybe you can change it to wireframe. If you put it in shaded wireframe, we can see the cube, we can see the wheels, and also we can see this white thing. This is the plane. Okay, so maybe let's leave it at wireframe. So let's put it in the wheels. So we have that so far, and now what we are gonna see is gonna be the physics debug window reference. Use the physics debug window to configure and generate visual representations of 3D physics activity in a scene. These visualizations appear in the scene view. To open the physics window to open the physics debug window in the Unity editor, go to the window, analysis, and physics debugger. So let's close this one. We are gonna go into the window, we are gonna go into analysis, and then it's gonna be physics debugger, so like this, and it's gonna open this window, and here we have the info. Okay, we can make this one bigger, so we have the info. Okay, we have the filtering. Okay, so we have show physics scene. As you can see here, we have the rendering, we have the contacts, we have the queries, and other, and you can reset it. So this one is to make it bigger, smaller. Okay, let's just leave it info for now, or just filtering. We have these three dots, so you can pretty much close the tab, add tab, so you have scene, game, inspector, hierarchy, project, profiler, animation. You have the UI, toolkit, live, reload. Okay, so if we go into the car root, you can see we have the rigid body, we have the C sharp, the C sharp script. Okay, and if we go into the cube, well, we have the transform, we have the cube, the mesh filter, we have the mesh render, we have the box collider. Okay, we have the default material here. Okay, so we already opened it here. Now physics debugs inserts a physics debug panel in the scene view and opens a physics debug window that contains the following tabs. So we already saw this one, the info, the filtering, the rendering, contacts, and queries. So the info, track or rigid body and articulation body information, center of mass and inertia, tensor visualization can also be found here. So this is the info, where it was. I think I close it, but again, you go to window, you go to analysis, and then you go to physics debugger. Okay, and let me see, close tab. No, that's, and you can pretty much, I mean, if you drag and just drop it here, let me see if we can do this. Oops, yeah, pretty much I did that. So I just drag it and drop it here, but I can pretty much undock it, I guess. Let me see, close tab, or let me see if I can, yeah, I can pretty much, if you grab it. Okay, so now I put it over here, physics debug. Let me see if I can just move it here. So you can just pretty much just drag it and drop it wherever you want. Maybe I can put it, I don't know, well, maybe I can put it close, yeah, here to the side of the inspector. Now you have the inspector, and now you have the physics debug. So, and as you can see, we have the info. Now we also have the filtering, determine which physics objects should be shown. So let me see, we have the filtering, and here we have the show physics scene, we have the show Unity scene, show layer, show static collider, show trigger, show rigid bodies, show kinematic bodies, show articulation bodies, show sleeping bodies, and then also we have the collider types. We have the show box colliders, show sphere colliders, we have the capsule colliders, we have the mesh colliders, and terrain colliders. Now we're gonna see the rendering. Okay, rendering settings that define how Unity renders and displays the physics visualization. Now let me see rendering. Yeah, this is the one. So we have the static colliders, and let me see. Oops, we have that one. Okay, I think it was. Let me see if I can reset it. So let's just reset it. Okay. You have the static colliders, you have the triggers, you have the rigid body, kinematic bodies, articulation bodies, sleeping bodies, variation. We have transparency, force, overdraw, view distance, terrain tiles max. Then we have the gizmo settings. Okay, now we have the contacts. Select whether or not contacts should be visualized. Let me see what do we have here in contacts. And we only have the contact color, contact separation color, and contact impulse color. Okay, queries. Select whether or not query should be visualized. To revert the physics debug window back to its default setting, just select reset, as we already did that. If you start messing around, let's say I wanna click here, hit this one, and I don't know, maybe I just wanna pretty much use this color, so I'm playing around. You just click reset and it's gonna set the values to the original values that were in. Now the queries. Okay, select whether or not query should be visualized. Okay, yeah. For more information on improving physics performance on your project, you can see the documentation of the physics profiler. So yeah, I think we already no, we didn't cover this one yet, but you can check it out, the physics profiler module. And let me see, this is part of the working with Unity. Okay, this is in the part of analysis, we haven't touched that one yet. Now we are here, the physics debug panel. Okay, when the physics debug window is open in Unity, the physics debug panel appears in the scene view. By default, it appears in the bottom right corner of the scene view, so in the bottom right corner. Okay, so we already did that, but we already duck it here close or to the right side of the inspector. Okay, let me see the corner view. However, you can click and drag to move it around, so that's where we already did that. So property, we have the collision geometry. Enable collision geometry to visualize collision information in the scene view. Disable collision geometry to hide collision information in the scene view. So let me see, we have other here. Oops, reset, and we can just leave it like that. Contacts, query, filtering. Okay, we also have mouse select. Enable mouse select to enable mouse over highlighting a mouse selection. This is useful if you have a large game objects that obstruct each other in visualization. So we have the info that we already checked out. Yeah, the info tab contains data about any selected rigid body or articulation body game objects. You can use this data to monitor the physics behavior body. You cannot edit these property values in this tab. You can modify them via script, but it is not recommended. In most cases, you should apply forces via this physics system to change these values instead. To keep a specific game object permanently tagged in the info tab, enable lag for the game object. And pretty much what they're saying is, if you go here, let me see if I click okay, so I can click this one, this little lag, and pretty much I will be able to lag it. Let me see if I can move this one here and just put it. Okay, so now I have it close to the scene, close to the game. Now I have the physics debug, so I have it right here. Let me see if I can go down here and just put it here. So now I have the console, the project, and here I have the physics debug. And let me see, close tab. Yeah, okay, so right now it's pretty much tagged here. Okay, let me see. Okay, so now the properties, and you have the description here. We have the number of items per row, we have the track objects, we have the clear lag objects. We also have the info tab displays the following properties when you select game objects in the hierarchy that has a physics body, that is the rigid body or an articulation body. So we have the property, the game object, the draw gizmos for. You have the center of mass, inertia tensor, lag, speed, velocity, angular velocity, inertia tensor, rotation, local center of mass, world center of mass, sleep state, sleep threshold, max linear velocity, max angular velocity, solver iteration, solver velocity iteration, body index. Now we have the filtering. Okay, we are just gonna move it here and just put it to the side of the inspector. So now we have the filtering. Okay, we have the, let me see, the filtering. What do we have in the filtering? Again, we have the show physics scene, show unity scene, show layers, static colliders, show triggers, rigid body, show kinematic body, show articulation bodies. Then we have the rendering. Okay, so rendering here. And we have the property, the description, the static colliders, the trigger, the rigid body, kinematic body. So we have all that. The contacts, you have show all contacts, show impulse. Okay, so we have queries, show color, show shapes. Okay, so we have that. And now let's move into the box collider component reference. So if we go into the car root and we go into the inspector, you are gonna see, well, let me see, transform rigid body. No, here we don't have it. But if we go inside into the cube is the child component, and the car underscore root is the parent of this cube child component, and this cube has a box collider. Okay, let's just leave it like that for now. So we have this box collider, and as you can see we have the edit collider, and if you click here you can make this one bigger, smaller, or wider, and I don't know, thinner. You can play around here. And let me see, in these three dots we have if you start messing around with these values, you can reset it. You can remove this component, move up, copy, find reference, properties. Okay, you have this property of the cube. Okay, so material name, and let me see what options. Okay, we don't have options. So you have the center, x is 0, y is 0, and z 0. The size of x is 1, the size of y is 1, and the size of z is 1. Then we also have the layer overrides. We have the include layers, exclude layers, and override. Let me see this one. Let's set to layer override priority is set to 0. Okay, so we have that. So this is very small, so let's just give it a try. So the properties, let me see, is trigger, and then we have provides contacts, material, center size, and layer override. So okay, so as trigger, if enabled, this collider is used for triggering events and is ignored by the physics engine. So let me see if it's enabled. As trigger, no, it's not enabled, so it's unchecked. We can check here, and now pretty much if enabled, now we have enabled it. This collider is used for triggering events and is ignored by the physics engine. So this time this cube now is going to be ignored by the physics engine, so we can uncheck it. Material, reference to the physics material that determines how this collider interacts with others. Okay, so now it's gonna be this one. So by default it's being set to none, but if we go let me see if I have, no, I don't have here the prefabs, but I don't know, maybe we can grab a cube here and just move it around, so we will have a material, but right now it's pretty much just none, so we don't have any here. Okay, so now center, the position of the collider in the object's local space. Let me see how we have the center here. So the center is, yeah, pretty much in the, we have x 0, y0, and z0. Okay, so that size, the size of the collider in the xyz directions, and it's gonna be 1 by the yeah, it's gonna be 1 for each value. Now some details. Bags colliders are rectangular cuboids and are useful for items such as crates or chests. However, you can use a thin box as a floor, wall, or ramp. The box collider is also a useful element in a compound collider. To edit the box's shape, press the edit collider button in the inspector. So to edit the box's shape, press the edit collider button in the inspector. Let me see, edit, this one, edit collider, so we can click here. Okay, and you can see, let me see, edit bounding value. Hold all after clicking control handle to pin center and place. Hold shift after clicking control to scale uniformly. Okay, so let me see if I can hold all after clicking control to pin the center, so we press all. Okay, and then we can shift after clicking, hold shift after clicking control handle to scale uniformly. Okay, so shift, oops, and let me see. Okay, so I am moving it with the shift here, and I can place this one around. Oops, nope, I don't want to do that. Let me see. Yeah, I can play around here, this one. Let me put this. Yeah, no, we are still in the cube. Let's click here, and let me see. Oh, okay, oops. As you can see, when I press Alt, we have this pretty much kind of like these dots, but if I click it here, you can see pretty much that it becomes the Cartesian, the Y, the X, and the Z plane. So the Cartesian plane. Okay, and let me see, a vertex. Okay, to exit the collider's edit mode, press edit collider button again. A vertex appears in the center of each of the face of the box collider in edit mode. To move the vertices, drag them with the mouse when the mouse is over the vertex to make the box collider bigger and smaller. Okay, we did that. And now we're gonna have the capsule collider component. So in this particular example, we don't have a capsule, but we can pretty much right click in 3D object and then capsule. So we have that, and as you can see here, let me see, I can just grab this capsule and I'm gonna, okay, I can leave it here, but what I'm gonna do is I wanna make the capsule the child of the parent car underscore root, so it's gonna be at the same level of the cube. And let me see, yeah, now the capsule now has the parent is gonna be the car underscore root. So if we go into the capsule, we have this capsule collider. So again, we also have the same thing. If you edit it, so as you can see, this we are in the 3 dimension, but once I click here and edit bounding volume, hold all after clicking control handle to be in center and place, so we can have that. And let me see this one. Okay, so now we are pretty much playing around here with these values, and if I click shift, I can pretty much I click in one of those dots, and now I am pressing shift and playing around with the mouse, so you can move this one around, so you can pretty much make this one bigger or smaller. And oops, we need to go here, we need to click here this one, and let me see. Let's leave it like that, and let's click it again. Oops, let's click it again, let's click in this dot, and oops, no, now I grab I need to grab the capsule, and let me see, let's just click here. Okay, so now I'm pretty much playing with the shift. Now I'm gonna play with the alt. As you can see, when I press alt, so I'm pressing alt and then playing with the mouse, so it's gonna be, it doesn't affect the Y part, so it's pretty much only messing around with the with the width of this object or the capsule collider. So as you can see, now I'm gonna press shift. Now I can make it bigger, going pretty much into the Y coordinate system. Now if I press alt, now I'm pretty much playing into the kind of like to the Y component. Okay, so we have that, and again it's gonna be pretty much similar, but the capsule collider is made of two half spheres joined together by a cylinder. It is the same shape as the capsule primitive. So again, this one, let me see if I can just go here, and instead of wireframe I'm gonna pick shaded wireframe. So oops, maybe it's too wide for you. Okay, so I'm just gonna move this one maybe like that, and maybe just put it here. So then I'm gonna click, oops, no, what is the capsule? Okay, and I'm gonna just leave it in wireframe. As you can see, this is the one that is in orange is the capsule, but the one that is in green is the capsule collider. So we can click here, and you can just click shift, and you can click in any of these dots, and pretty much we can play around. And if you see to the right bottom corner, you can see the radius is changing from 0 point something, and now it's went over 1.17, and the height also has increased. Okay, so now if I click let me see, now I click alt and then shift, and again the height is pretty much the same, but now the radius is changing. Okay, now what do we have here? So the property, so it's trigger. If enabled, this collider is used for triggering events and is ignored by the physics engine. So it's pretty much the same. Now we can, it's pretty much a trigger, material, center, radius, height, and direction is pretty much the same, but let's check out the details. You can adjust the capsule collider's radius and height independently of each other. It is used in the character controller and works well for polls, or can be combined with other colliders for unusual shapes. So again, here we have this, as you can see, we have the radius and the height, and here in this capsule collider we have, this is, well, it's going to be the height, this whole thing from the very top to the very bottom. This is the standard capsule collider, this is the height, and from here, from the very top to this part is going to be the radius. So right now the radius is 0.5 something. Let's just move it to 0.1 maybe. So this is the radius, and I don't know, maybe let's just change it to 3. Okay, and you can play around 5, 6. So let's check, let's just keep it to 0.4. so as you can see, it's gonna be inside, and as you can see, this is the way that it's looking. Let me see if we can go to shade it. Okay, yeah, maybe like that, or shaded where, yeah, maybe shaded. So we have that so far. And yeah, I don't think it's gonna be appreciated. Maybe in wireframe is better. Yeah, wireframe. Okay, so we have that. And now let's check out the terrain collider. So the terrain collider component reference. And again, we let's save it for now, and we are gonna right click, or you can just go into the game object and just pick 3D and then just terrain. Okay, so we have a terrain, and I'm just gonna make it a child of the car root. So just grab it and drop it inside of the car. So now we have this terrain, and again, as you can see, we have the terrain collider here. So you are gonna see the provides contacts, material, terrain data, enable tree colliders, and the layers override. So we have the layer override priority, include layers and exclude layers. So let's check out. So the terrain colliders implements a collision surface with the same shape as the terrain object it is attached to. Okay, in this case we have non-physical materials and non-terrain. Now, again, we have the material, terrain data, enable tree collider. So material, reference to the physics material that determines how this collider interacts with others. Terrain data, the terrain data, enable tree colliders. When selected, tree colliders will be enabled. Okay, so some details. You should know that version of the Unity before 5.0 had a smooth sphere collisions property for the terrain colliders. In order to improve interaction between terrains and spheres, this property is now obsolete since the smooth interaction is a standard behavior for the physics engine, and there is no particular advantage to switching it off. Okay, so that's some cool information. Okay, so let me see if this game has been modified. So we have added this sphere, but okay, so okay, as you can see now, the sphere and this cube are the child of the car underscore root parent. So that's the parent. So now not only the sphere, oops, oh man, it collided, man. That's yeah, not only the cube, but also the capsule is following around. So because they are the child of the parent car underscore root, and now they have collided. So let's play it again. Let's play it, and yeah, we can move around. We are playing it here, and okay, so let's just make this one bigger, and like that. Then oops, I can make this one back. It's coming forward. Let me see where it went. Let me see. Okay, so they're kind of, whoa, let's move them here. I just don't see them, so we lost them. Maybe we lost them, so let's click it again. Let's move it backwards. Let's check it out. Let's move it forward. Let me see if we can move this one forward. Okay, so we are making kind of like going in circles, and yeah, I mean the sphere is following the cube, so that's kind of like whoa, kind of cool so far. Let me see if we can go, oops, too much speed. Maybe we can go back. I don't think so. Maybe. Okay, so we are okay, so let's just unclick it, and now we can go into the layout here and just click in default, so everything is back to normal. Okay, so that's fine. And let me see where is the terrain. So let me see this one. What is terrain? So okay, so this is the terrain, and let me see that. Okay, so we have a terrain, and this one is the plane. Okay, so then we have the terrain. Yeah, that's fine. Yeah, that's fine so far. Now Let's continue. So we have the wheel collider and wheel collider. So let me see something real quick here. Let's just go into the cube. Okay, we can just leave it like that. Now, the wheel collider component reference. The wheel collider is a special collider for ground vehicles. It has built-in collision detection, wheel physics, and a slip-based tire friction model. It can be used for objects other than wheels, but it's specifically designed for vehicles with wheels. So if we go here, let me see if I can add something here. 3D objects, same. Let me see, capsule, sphere. So this would be wheels. Let me see if we go into the, I don't know, wheels maybe, and let me see from left. Okay, as you can see, and you go into add components. So let me see, yeah, wheel collider, so you can grab it from here. But as you can see here, the wheel collider, we have the mass, the radius, the wheel damping rate, suspension distance, force up, point instance. We have the suspension spring, forward friction, sideways friction, layer override. So let's check it out. Yeah, pretty much we have all this information, and this is the properties. So the mass, the radius, the wheel damping rate, suspension distance, force up, point distance, center suspension spring. We have the damper, target position, forward, sideways. We have the friction, and here, I mean, they're giving us this example. We have the inspector. We have the wheel collider, mass 2, radius 0.36, suspension 0.1, and in my case the mass is 20, the radius is 0.5, the wheel damping rate is 0.25, suspension distance is 0.3. Okay, now some details. Okay, so let's check out the details, and let me check something. Okay, so details. The wheel's collision detection is performed by casting a ray from center downwards through the local y-axis. The wheel has a radius and can be extended downwards according to the suspension distance. The vehicle is controlled from the scripting using different properties: the motor torque, brake torque, and steer angle. See the wheel collider scripting reference for more information. The wheel collider computes friction separately from the rest of the physics engine using a slip-based friction model. This allows for more realistic behavior, but also causes wheel colliders to ignore standard physics material settings. So the wheel collider setup: you do not turn or roll wheel collider object to control the car. The objects that have the wheel collider attached should always be fixed relative to the car itself. However, you might want to turn and roll the graphic wheel presentations. The best way to do this is to set up separate objects for wheel colliders and visible wheels. So here we have the car root, the wheel colliders, the wheel models. Now we have also the gizmos. Let me see if we have it here. I think it was this one. Okay, let me see. Note that the gizmo graphic for the wheel collider position is not updated in play mode. Okay, that's fine. Collision geometry. Okay, so because cars can achieve large velocities getting racetrack, collision geometry right is very important. Specifically, the collision mesh should not have small bumps or dents that make up the visible models, e.g. fence poles. Usually collision mesh for the racetrack is made separately from the visible mesh, making the collision mesh as smooth as possible. It also should not have thin objects. If you have thin track border, make it wider and a collision mesh, or completely remove the other side of the car if the car can never go there. So we have that. Visible geometry left is much more complex than collision geometry right. So as you can see here, we also have the wheel friction curves. Okay, so let me see something real quick. Yeah, the wheel friction curves. Tire friction can be described by the wheel friction curve shown below. There are separate curves for the wheel's forward rolling direction and sideways directions. In both directions, it is first determined how much the tire is slipping based on the speed difference between the tire's rubber and the road. Then this slip value is used to find out the tire force exerted on the contact point. The curve takes a measure of the tire slip as an input and gives a force output. The curve is approximated by a two-piece spline. The first section goes from 0, to extreme up slip extreme value, at which point the curve's tangent is 0. The second section goes from extreme slip extreme value to asymptote slip asymptote value, where the curve's tangent is again 0. So you have this example that are given us. So we have the force, we have the extreme and then we have the asymptote and then the slip. Typical shape of a wheel friction curve. And again we have the extreme slip value, asymptote slip value, and then we have the stiffness. Then okay, so we have the stiffness multiplier of the extremum value and the asymptote value. The false one changes the stiffness of the friction. Setting this to 0 will completely disable all the friction from the wheel. Usually you modify stiffness at runtime to simulate various ground materials of scripting. So this is pretty much what we have for the wheel collider component reference, and let's check it out here. So the wheel collider, the wheel collider, we have the suspension spring, we have the forward friction, the sideways friction, and finally the layers override. And you can pretty much go inside of these ones, and as you can see here in the forward friction we have the extreme and slip extreme and value, asymptote slip asymptote value, stiffness, so the one that we were talking, and pretty much we have the same here. Sideways friction, again we have the extreme slip extreme value, asymptote slip asymptote value, stiffness, and then we have also the suspension spring, the damper, the target position.